Okay, so this is going to be an extremely short video. What I want to do is just go through a couple of examples with you about the distributive property. And we need to, first of all, with example 1, simplify the expression. And that expression is 2 times the quantity 5x plus 3. And the first thing you need to know is this 2 right here is being multiplied by all of this in the 5x plus 3 portion. And what we need to do is simply multiply 2 by this term and also this term. Okay, so then what we do is 2 times 5x will give you 10x for the first one, and 2 times 3 becomes 6. And so simplified, I have 10x plus 6. Again, that's example 1. I simply needed to multiply 2 times the 5x to give you the 10x, and 2 times the 3 to give you 6. And that's my answer with the x being first. Okay, example 2, I have 2 times the quantity 3 minus 7t. Again, what I need to do is show my little arches, being 2 times 3 and 2 times negative 7t. And when I do 2 times 3, it will give me 6, of course, and 2 times negative 7t will give me, first of all, negative 14 for my number, and then I leave the t there. So 6 minus 14t. Now, that's simplified. However, the only problem is I need to always remember to write my variable term first, which is this negative 14t. Not just 14t, but negative 14t. And then you don't really see it, but there's kind of an invisible plus 6 there. So what I need to do is write the negative 14t first, and then write plus 6. That's in simplified expression form. Example 3, I have negative times 6x plus 4. Well, what does that mean, just negative? What it means is it's like there's an imaginary 1 in front, so it's negative 1 times all that, and you treat it as normal. So again, negative 1 times 6x and negative 1 times 4 will give me negative 6x. And then negative 1 times 4 will give me negative 4. My variable term is in front, and I'm already all done. Okay, so what happens if I have this 0.4 plus 1.1c all times 3, and the number that I want to multiply the big set of terms in is off to the right instead of the left? Well, you can do one or two things. You can either reverse the process, like 3 times 1.1c and 3 times 0.4, and then do 3 times that would be 3.3c, and then plus this 3 times the 0.4, which is then going to be 1.2, and I'm all set. Or what you could have done is just simply rewritten this this 3 out front, and then done 0.4 plus 1.1c, and just do it like you have done in the past, and get your answer. Okay, there's somebody giving announcements in the background, just ignore it. Now I want to talk about combining like terms. What if I have something like 3x squared plus 5x squared? The first thing I want you to notice is that x squared and x squared are the same term. They're like terms. If I would have had an x squared and just an x, those would be different terms. So these are like terms. So what we can actually do is pull out just an x squared out front and then really focus on the 3 plus 5. So then I would group that as 3 plus 5 x squared, and then I would simply be able to add inside parentheses there to give me 8x squared. And as you can see, you can just quickly look and say, okay, these are like terms. 3 and 5 give me 8, so then I have 8x squared, and that's my final answer for that. Two more quick problems. If I look at the y's are like terms, so I can take 7 and 6 and make 13. That gives me 13y. Quick as that. 3t minus t. Whoa, what do I do with that? I simply write an imaginary 1 in front of the t, because again, that's always there. You need to know that. 3t minus 1, or 3 minus 1 gives you 2, and t stays there. It's a like term. You're done. Alright, last two problems. If I look at this, I see w to the third in part D here, and I simply want to focus on my negative 9 and my negative 3. Negative 9 plus negative 3 as integers becomes negative 12, w to the third. And as I look over at part E, I see 4x squared minus 3x. Now be careful. Are they like terms? or are they not? The answer is they're not. So what do you do with them? You have it simplified as much as you can simplify it, because you can't combine any farther. So that's the way you leave it. Okay, this was distributive property, as well as I threw in some combining like terms. Be ready to do this in class. And again, this was a really quick video.